Very good evening and selamat sejahtera to Sir Amir Izani. Today I'm going to present my test 3 fundamental and circuit analysis 1 lab. So my name is Suman Analaki Ramesh, section 02, ID number TG20023. So let's go for the part 1. First we have to build the resistor network according to the circuit diagram as in figure 1. And measure the VRMS and IRMS with a digital multimeter, and then we use record the VRMS and IRMS and also calculate the power dissipated at each resistor and record. So this is the circuit of figure 1, and let's go to the multisim. So I've done a two circuit, which one for this is to measure the voltage and this is to measure the current. So now for the voltage, let's run. Okay, so since it's in parallel, the voltage across each resistor is 12 volts, and for the current, since the current should be in, sorry, so okay, for the current at R1, for current R1 is 6 milliampere, current R2 is 3 milliampere, R3 the current is 2 milliampere, and R4 the current is 1.5 milliampere. Now based on these two data, we have to record them in the table and calculate the power dissipated. So now this is the data that we record, and this is the power. So power, we use the formula P equals to VI. So for R1 we use P equals to VI 12 times 0.006, we get 0.072 watt. For R2, 12 times 0.003, we get 0.036 watt. R3 we get 12 times 0.002, we get 0.024 watt, and R4 is 12 times 0.0015, we get 0.018 watt. So the calculation and the answer, this is the calculation and the answer we record in the table 2. So now let's go for the part second. By referring the figure 2, predict V peak and V peak to peak across the loads, and also measure V peak and V peak to peak using oscilloscope, and record the predicted and measured in table 3. After that, measure the secondary voltage of the transformer and draw the output waveform to figure 3. So this is the figure 2. So based from figure 2, okay. So based from figure 2, we need to find the V peak and V peak to peak. So for one, I use this oscilloscope. So okay, it's all set, and run. Okay, we pause to make sure the graph is much more bigger, so I decrease the. Okay, so now to find out the V peak and V peak to peak, I use this method. Okay, go to Y max. So I set these two arrows, one go to the Y max and another one go to the Y min. So now at the Y max, okay, so for the one is the 1.694. So this is the voltage peak, and for the voltage peak to peak is 3.389. So this is for R1, and for R3, R2, R3, and 4, I use a quick method. So okay. So there you go, and we run. So we can see here the VRMS for R2 is 2.40, and V peak to peak is 6.78. From V peak to peak, we can actually calculate the V peak by dividing 2. For R3, the VRMS is 3.6. For VRMS is 4.08. But for the actual experiment, I use oscilloscope for all this resistor. So my value will be in the 3 decimal point. So here, so this is the value that I got using the oscilloscope. So for the predicted result, here's my calculation. V peak and for V peak to peak R1. First, I need to find the VRMS. So VRMS for R1 is 1.2 volt. Now using the 1.2 volt, I can find V peak by multiplying VRMS by dividing 1.2, which is VRMS, with 0.7071. I get 1.967. For V peak to peak, I multiply by 2, I get 3.394. R2 VRMS is 2.4, V peak is 3.394, V peak to peak is 6.788. R3, the VRMS is 3.6 volts, the V peak is 5.091, the V peak to peak is 10.182. VRMS for R4 is 4.8, V peak is 6.788, V peak to peak is 13.567. And for the voltage, then we need to measure the secondary voltage of the transformer and draw the output waveform. So the output waveform, okay, so let's go to the multi-scene. We pause, okay, stop, delete this. So the secondary voltage is here. Okay, so this is our graph here, but then since it's we cannot see the whole graph, I try to increase the scale. So okay, so now this is the graph and the waveform of secondary voltage. So the scale is 10. The scale is 10 for time base is 10 millisecond per div. Voltage base is the 10 volts per division. So now let's go for the part 2. Is okay, so we have to calculate the capacitive reactance and total impedance for the network. So this is the circuit. We have 100 volts peak, 50 hertz, R1 is 10 and C1 is 100 micro farad. Okay, so for the calculation for capacitive reactance, Xc equals to 1 over 2 pi times F times C. So F is the frequency, C is the 100 times 10 power negative 6. So Xc is 3.131.831 ohm. Now calculate the total impedance Z. Z equals to power root in R square plus XL minus XC square and power root. So now we only have XC here, we don't have RXL. So Z equals to 10 power square plus negative 31.831 square and power root the answer. So we get 33.365 ohm. Now calculate the current flowing into the capacitor. Since the capacitor and resistor in a parallel in a series, so the voltage, so the current at R1 and C1 is the same. So now V peak is equal to Z times I peak. 100 is the V peak equals to 33.365 I peak. I peak equals to 100 divided by 33.365. I peak is equals to 2.997. Now this is I peak. We need to find I, which is IRMS. So IRMS equals to I peak times 0.7071, and we can get the I is 2.18 for the capacitor. calculate VR, VC, and VS. Now we already got the current, and we also already got the value for R, C, and Z. Now for VR is equal to R times I. 10 times 2.12, so equals to 21.2 volt. For VC is XC times I, 31.831 times 2.12, which is 67.48 volt. Now for VS is Z times I, it is 33.365 times 2.12, and we get 70.73 volts. Now D. Calculate the phase angle between the current and voltage. So to find the phase angle between the current and voltage is by using this formula. Tan theta is equals to negative VC over VR. Tan theta is equals to 67.48 negative 67.48 divided by 21.2. Now we need to find the theta. So the theta is negative 72.56 degree. So that's the phase angle between the current and the voltage. Okay, now measure the voltage R and voltage C with oscilloscope and draw the output waveform in figure 5 and figure 6. So this is the waveform for VR, and this is the waveform for VC. We use okay. So figure 3, and we run. Okay, we pause. So let's go to the graph and so okay, this is the output waveform for R1, and this is the output waveform for C1. And let's go to the so here is the time base for the R1 VR is 10 millisecond per division, and the voltage base is 20 voltage per division. And for the C1 voltage at capacitor is the time base is 10 millisecond per division, and the voltage base is 50 volt per division. So that's the end of the questions. Thank you.